Let's dive in. Okay, so we want to define an integer's roundness as the number of trailing zeros in it. Okay, so you might have heard this term like leading zeros before. Usually when we're talking about leading zeros, we're talking about things like you might have it in a string like 0001, okay? Whereas if we were to typecast this to a number, it would just be the number 1. It would ignore all the leading zeros. So leading zeros are kind of a big deal that, well, in some cases, we've had to deal with those. Often it's like an edge case for a lot of challenges that like, oh, you forgot about if it has a leading zero. Anyway, the point is, in this case, we're not talking about leading zeros. We're talking about trailing zeros. So no surprise there. It's the zeros on the other end. Okay. So basically the roundness is the number of trailing zeros. So basically the roundness of this one, it would be 2. That's basically the idea. We want to check, given an integer, we want to check if it's possible to increase this number's roundness by swapping some pair of its digits. So we're going to look at a few ways of doing this. In this case, it's returning true because we would be able to swap some pair of digits here that would increase the roundness. So like, for example, just like swapping this 1 and this 0 over here, that'd do it, right? We'd have an extra 0 on the end, but we could do better. We could swap this 1 with this 0 over here, and we can make the roundness as big as 5. Maybe it would be like a spin-off kind of challenge for them to ask what's the greatest roundness you could get from the number given some swap of 2 digits. But in this case, they don't need to know that. So like whether we're swapping these 2 here or whether we're swapping the 1 with this 0 over here, it doesn't really matter. In either of those cases, we're increasing the roundness. So we would return true either way in both of those cases. Okay, so we're going to look at a few ways of doing this, like I said. The first way I want to do it, and I don't think this is going to be surprising to any long-term viewers here, I'm going to try to interpret this in the most straightforward, most literal possible way. So the very first thing I want to do is if we're going to have to check for a number's roundness, I want to define a function that's going to find its roundness. And I'm going to call it roundness. And it's going to take in a number, and basically it's just going to return the number of zeros. Hold on. Instead of zeros, let's call it trailers. Yeah, that's better. Trailing zeros, right? And we want to return the number of trailers. Okay, so let's go through the number. This is a strategy we're sort of used to doing where we say something like, well, typically we do something like this, you know, like while num, and then we want to pick apart the digits. So we'll say like let digit be assigned the value of num, mod 10. And then we would say num is assigned the value of math.floor of num divided by 10. So this is a typical strategy when we're trying to pick apart all the digits. The thing is, we don't need to pick apart all the digits here. All we need to know is that last digit, is it 0? And as long as it is 0, then we're going to do this. Yeah, we're going to truncate the number. We're going to basically get rid of the final digit. And then we're also going to count trailers. We're going to iterate by 1. So we're going to say, there's 1 more than you thought there was. So we start with 0, and then we say, oh, well, that's a 0. So let's increase the number of trailers, and let's cut that thing off. Let's divide by 10 and take the floor of that. And then the next time we say, okay, so num mod 10, is it still 0? Oh, it is. Okay, trailers plus plus again. So it'd be up to 2, and then we'd truncate that away. We'd look at our next digit. We'd say, okay, num mod 10, is it equal to 0? No, it's not. It's equal to 1. Okay, so then we'd stop there, and we'd return trailers. It was 2. Makes sense. It should be 2 in that case. So one thing I just wanted to say about this, normally this is really important to put the math.floor because otherwise when we divide by 10, you know, let's say we were at this point over here and we divide by 10, so now we'd have like, oh boy, where are we here? 902,200.1 if we divide that by 10. So we would have to do a floor normally, but in this case, we're specifically talking about the cases where the last digit is 0 anyway. So it's not actually going to make a difference if we do floor or not. We don't have to do floor in this case. We can just say num is assigned the value of num divided by 10. And Rainbow asks, can't you one-line that with a comma? Yeah, I mean, there's probably a way to one-line, like this stuff in here, like inside the loop, you mean? Let's see. Or wait, did you mean like the whole function here, like using an arrow function or something like that? I suspect both of them would be possible. But yeah, so for these, one-line it with a comma, well, okay. I don't think I would want to one-line this one, and the reason is just because like these are two pretty different commands. If I was to try to put these together, I think it would get like it would start to look a little hacky because I would be doing stuff like this. You know, I would probably be saying something like num is assigned the value of num divided by 10, and then I would probably have to do something like plus trailers plus plus, or actually let me do plus plus trailers so that it adds it on first, and then I'm going to subtract trailers. So basically that's a way you could do it, you know. So this is basically just like adding 0. We're sort of condensing it all into one line, but it feels like this is probably not going to be worth it in terms of how much clarity we sacrifice in doing that. So let's go back to this point over here. I suppose I should actually check to see if this function's working. So roundness of n. Let's just return that right off the bat. So this one has a roundness of 3. Oh, okay, hold on a sec. So Rainbow's suggesting we do something like this. So put the comma in there, something like that. Let's try running that. We'll see if it works first of all. It doesn't seem to be working. We're getting 2 in this case. So yeah, I'm not sure. I have seen the comma being used in some cases, like it's in particular in arrow functions. I've seen it used that way. But for whatever reason, it doesn't seem to be working the way we want it to here. So maybe we'll just leave it like that for now. But let's see. Okay, yeah, so our roundness function is working. Let's actually do something with it now. So what do we actually want to do? Well, we have a way of checking roundness. What is the problem actually asking though? So it's asking, if we're given n, is it going to be possible to increase the roundness by swapping some pair of its digits? So to do that, basically I'm going to swap each pair of digits, you know, I'm going to run through a loop. I'm going to say for let I be assigned the value 0, I is less than, I'm just going to put in the word length over here. I realize I haven't defined that yet, but I will in just a sec. And just structuring these loops is giving us an idea of what other sort of technology we're going to require for the rest of the solution. So let's just write these in, and okay, so we need a length. I'm actually, just to make the swapping as easy as possible, I'm going to convert this to an array, actually. So I'm going to say const str is assigned the value of n dot toString. I'm not going to put in an argument for toString because I want it to be in decimal. If I wanted to be absolutely airtight about this, I could put it in a 10 for decimal, but that's implied. So, okay. We've got our string. Length is going to be the length of that string. And then we'll do like, let's just call this base roundness. And it's going to be assigned the value of roundness of n. Okay, so just whatever the roundness was right off the bat at the very start here. So Rainbow says, I heard it returns the right-hand value. Maybe plus plus trailers, I don't know. Yeah, let's give it a try. Just, why not, right? Roundness at n. So, okay, just to make sure this one is working. And did I hit Control R or Control Enter? Yeah, Control R. Okay, good. So yeah, that one was 3. This one was 2. So that's good. And let's give that comma strategy a try. So plus plus trailers. Let's try. Oh, I did hit Control Enter that time. My mistake. Sorry about that. Okay, so this one, it's still saying 1. Yeah, that's actually a bit further from our result. So I'd have to look into this. I'd have to look into this comma business here. But yeah, like I said, I have seen it used, and the main place I've seen it used is within, what do you call it? Yeah, arrow functions. So when you need to do an arrow function and you need to do more than one calculation, but you don't want to have to use a return statement, that's usually where I've seen that done. I have seen commas used in a couple other situations, but yeah, I'm not sure. In this case, for whatever reason, it doesn't seem to be working. I mean, hey, look, we could use a destructuring assignment. Like, if you really want this to be one line, we could do something like trailers num is assigned the value of trailers plus 1, and then num divided by 10. Like, this would work. This would be a totally fine way of bringing it to one line, and I think that this is probably more clear to the reader than a comma strategy would be. It seems to be working as well. So, yeah. maybe we'll just go with the destructuring one for now. As for this stuff down here, so we have this loop that we kind of started. What do we actually want to be doing in this loop? Well, like I said, I want to use an array. So I'm going to say const r for array. And you might be thinking, well, didn't you say you wanted to swap the digits in that? Is it okay to use a constant for this array? Don't you actually want to be making a change to the array? And yeah, that's true. I do, but I think this is okay because my understanding here is that when we use constant, what we're actually doing is we're saying that the binding is constant. So the variable arr here, this is going to be referring to this particular array. We can modify the values within that array, but we're not going to modify the binding. So we're not going to later say, oh, and now array is like 257, you know, like we're not going to reassign it to some other array after. It's going to be constantly bound to this array, but what's inside that array might change. And it's going to, because we're going to swap the ones at I and j. So I'm just using a destructuring assignment here so that I don't have to use a temp variable, so that I can do it all in one line. This is really nice. I really like this. Now, keep in mind, there are other ways we could do this. We could use like a splice strategy or some other array tools, but the main thing is I think this is nice. It's good. It's pretty clear to the reader, I would say. Just swap the two values. And then we want our number from this. So I'll say const num is going to be assigned the value of, well, first of all, I'm going to have to parse int this thing, but I want to join that array. So we kind of went on a bit of a journey here. We started with a number, we converted it to a string, we converted the string to an array, we swapped two digits within the array, we joined that array back to a string, we converted it back to a number. So we have a number now, which is basically the result of swapping two digits within our original number, right? So kind of a roundabout way to do it. We had to go all the way to an array to do it. Well, okay, we didn't have to, but we did. We could have done just a string, you know, converted it to a string and used the string as a way to swap it, using like slice and that kind of stuff. We could even just do it with the number itself, you know, like we could use like division tricks and stuff like that to actually swap the two numbers. And now that I'm saying that, I'm starting to think like, why didn't I do that? I'm normally a bit of a math guy, right? You would have thought I would have preferred that strategy. Oh well, maybe next time. As for now, let's continue with this. So we've got our num here. This is the num that's sort of the result of swapping the two digits here. And then we basically just want to say if the roundness, whoops, let's spell that correctly. If the roundness of this number is actually greater than the base roundness that we started with, well, we don't need to do anything else. We'll just return true. I mean, at that point, we're saying, oh, wow, yeah, it worked. We were able to do this. We were able to find some pair of digits that we were able to swap in order to give us a more round number. So let's see if that runs. Let's try controlling R-ing that. It's not running, and I think it's because of this return up here, which means that none of this stuff was actually doing anything. So let's try running that again, and yeah, there we go. So it's passing all the sample tests, and there's quite a few of them in this case. 10 sample tests, that's nice. Good test coverage. I guess we might as well try submitting that, see if it passes all the hiddens. Ooh, and it does. Great work. Did that always say great work? Is that new? Either way, it's very encouraging, thank you. Okay, let's close that, and let's go back to the description for just a second over here. Okay, so we have one way of doing it, but yeah, I mean, this was a really, really literal way of looking at this thing. Like, this was pretty literal, I would say. So maybe there's another way we can do it. Maybe we can look at this in a different way. So the next way I want to look at it is basically just using numbers. So I'm going to Control A this, Control X. We're going to reset the code. We're going to press a few enters, and we're going to Control V that. Okay, and now we're going to throw a 1 on the end here so that it doesn't run for this. Let's just make sure the right function is working. So cool. All right, so what do we want to do with this? Well, let's get to the core of what makes a number more round. So basically the idea is that we want more zeros, right? So under what circumstances would we be able to do that by swapping digits? Well, okay, there's going to be some pool of zeros at the end here. Maybe it's none of them. Maybe it's some of them. Maybe it's the whole number, right? Maybe the whole number is all zeros. So we need a couple of conditions to be true for us to be able to actually increase the number roundness. Basically, what I'm going to suggest is that we start by just shaving off all the zeros here. and getting to a point where the last digit is not a 0. Now, if we get to the end of the number, then that'd be false, right? Like if we're taking off all the zeros and then there's no number left, well then return false. We got to the end. There is no way to increase the roundness. It's as great as it can possibly be. And actually, I guess if we get to the end, that means the number is just 0 because there wouldn't be any leading zeros otherwise. Okay. So we want to get to the end. We basically want to shave off all of the trailing zeros that are already in there. And then what other condition needs to be true? Well, in this case, we're able to swap, like, let's say the 1 with one of these other zeros. Really, if we swap this 1 with any of these zeros, we're increasing the roundness. Okay, so like there are ways to do it. Now in this case, we're not able to do it because after we shave off all the trailing zeros, there are no more zeros to draw from. So keep in mind, since we need to swap the digit with another 0, that's going to be really important. We have to, after we delete all the trailing zeros, there needs to be some 0 left over in our number there. Okay, so basically, let's do that. So here's our game plan. Actually, wait, let me make some space here. Shave off all the trailing zeros. Does it take any zeros? I'll put an E in. Okay. All right, shave off all the trailing zeros, and then after that, I guess if there's no number left, return false. Maybe we should specify that. We might not need to, like it might just take care of itself, just depending on how we set up the logic here, but might as well put that in there. If there's no number left, return false. What else? If there is a number left, then I guess we want to remove, actually wait, we should do that even before this. So remove the next digit. Okay, so like the 1 here, just remove that, right? Because then you just want to check if there is a 0 in the rest of the number. In this case, remove this 1, and then we just want to check if there is a 0 in the rest of the number. Okay, so let's do that. Remove the next digit, and then, yeah, if there's no number left, return false. Or if there's no digit left. I mean, yeah, that should be a relatively straightforward thing to do. And then at the end here, I guess just look for a 0, okay? And if we get to the end of the number without a 0, return false. So that's basically gonna be it. So shaving off all the trailing zeros, let's start with that. So we'll just say while n mod 10 is equal to 0. And n is not 0. That's really important because otherwise this could potentially be an infinite loop. So let's see. Yeah, okay, while that's happening, we're gonna say n is gonna be assigned the value of, and I am gonna use a math.floor in this case, or wait, no, I don't need to do that. I can just say n is assigned the value of n divided by 10. Later we'll use the math.floor when we're gonna look for the 0. Okay, so this is shaving off all the trailing zeros, and Rainbow, I'll click on that paste bin in just a sec. Yeah, we'll get through this one and then we're just gonna do another quick one and then I'll take a look at that. But your prediction is noted. Okay, so, yeah, that's right, n is not 0. Good, thank you. Yeah, very important. Okay, good stuff. Glad I have some help here today. Let's get back on track. So we want to remove the next digit after we've done all this. So this is where we're going to say n is assigned the value of math.floor of n divided by 10, because we do want to shave off the next digit no matter what it is, and we know it's not 0, so we will definitely need to take a floor on that. Let's just tighten that up a little bit. If there's no number left, return false. So I guess we might as well check that. If not n, return false. Yeah, we could do something like that. And then we want to look for a 0. So how are we going to look for the 0? I actually hadn't thought about that, but let's see. So this is going to be tough because we want, or wait, basically something similar to this, I guess, right? Huh. Okay, let's try that. So while n, I guess, right? We could do something like while n, and then we're basically just going to say if n mod 10 is 0, return true. You found a 0. Else, or we don't need to do an else. Let's just say n is assigned the value of math.floor of n divided by 10. And then if we get to the end here, return false. You didn't find a 0. Is that good? Is that going to work? Let's find out. Cool. So it's passing all the sample tests. That's great. Let's see if it passes the hiddens. Nice. Okay, cool. That's a nice one. I like that. It's totally within the realm of math. I think it's kind of neat. Like this one down here, it was really literal. You know, it's basically just taking this description in words and converting it into code. That's pretty much exactly what we were doing. You know, it's as literal as possible. Whereas this one up here, we're actually thinking about it. We're actually thinking like, well, under what conditions can we increase the roundness? And we then basically just systematically go through one step at a time to find if we can. So we take off all the trailing zeros, we remove the next digit, we check if there's a number left, and I'm actually wondering if this needs to be done. Like if I were to just remove that part, would it still pass all the tests? Would there be some kind of edge case that would prevent this one from working? I just feel like it might be taken care of by this return false over here. Yeah. Because basically, if there's no number left, it's not going to engage with the while n here. So, okay, that's even simpler. All right, I like that. I think that's a really, really solid solution here. So I'm gonna take all of it actually. Let's Control X all that. Let's reset the code. We'll confirm that. We'll put 1,000 enters in here, and then we'll put a 2 in front of that one. I think it's probably gonna be my favorite one, but I don't know. I have a feeling you guys are gonna like this next one. This is a bit of a fan favorite. So we've isolated the conditions under which the roundness can be increased, right? And what we found is that basically if there's a 0 before a non-zero, it's as simple as that. If there's a 0 that comes before a non-zero, you can increase the roundness. Yeah. Yeah, because that means, you know, like let's look at this situation where we have trailing zeros and then we have some non-zero number and then a 0 in front of it. Well, we're able to swap those. We can increase the roundness. If we're looking at this one, got a bunch of zeros and then we've got a non-zero, but we don't have a 0 in front of it, so we can't increase the roundness. Now, if we look at some of these other tests, yeah, that's an okay example. I want to take a look at one that, yeah, this is a better one. So in this case, you might say, well, this doesn't have any trailing zeros. How are you going to increase the roundness? Well, the roundness is 0, and that's fine. We can just swap this one with this 0 here, and we'll increase the roundness to 1. So that's fully possible. So basically, this is what I'm saying. If we have a non-zero digit with a 0 before it, then this'll work. That's all we need. That is the only condition that we need to check, actually. So all we need to actually return is basically, do we have a 0 followed by a non-zero in somewhere in our regular expression? We don't need to worry about like the start character or the end character. And we'll just convert this to a string since it's a regular expression. And we'll run that. And as it turns out, that's enough. We don't need anything more complicated than that. Now, I was looking into this earlier, and I thought we needed the toString, but as it turns out, we don't. So a regular expression apparently can work on just a regular number. We don't, I guess it's automatically typecasting it to a string when we put it in there, so that's kind of nice. All right, so let's just make sure it passes all the hidden, so let's run that, and yeah, there we go. So, nice stuff. We've got 3 different ways of doing it. Now, as nice and succinct as this one is, I do have to say, in a lot of ways, I prefer this. And the reason is because this doesn't typecast the number to anything other than a number. And that's generally going to be something that I look for. If we're dealing with just numbers and we want to deal with it as a number, then let's deal with it as a number. We might as well, right? Whereas in this case, despite how remarkably simple the code is, the fact that we're typecasting it to a string feels a little icky to me, I guess. Anyway, and yeah, Rainbow, I didn't know it either, so that was a surprise to me. Okay, so let's take a look at this paste bin over here. Let's see what you got. Oh, yep, that looks pretty familiar. Yeah, and I suppose I could have put the plus on this thing as well. So actually, hold on. Let me copy this over and paste it in here so everyone can see. Okay, so this was Rainbow's solution over here. Really, really similar to what we had. So just main difference, like we saw just a second ago, we don't technically need the toString. We don't actually really need the plus here because it's enough that there's one of them, right? That we have a 0 with something other than a 0 after it. The G, I mean, yeah, I like the G, but 1 is enough, so we technically don't actually need the G. G for global, right, which would look for all of them. So yeah, really similar though. Looks like we were on the right track, on the same path there, so good stuff. Let's see. We're all submitted here, right? We submitted that up? Yeah, okay. Everyone's good. Everyone's happy. Let's see. Yeah, I think that was it. I think that's all we wanted to say about this one. So basically, we were able to solve this one in a way that didn't require any loops. But like I said a minute ago, I do kind of prefer the one that did use loops for various reasons. Now keep in mind, this loop, like these might not go through the entire string, but they might. So because they might, we would say it has like a worst case time complexity of like big O of n, where n is the length of the number here. Which I don't think could be very big. Like, you know, you might be looking at this and thinking, what? N could be like 1 billion? That's huge! But the thing is, if n was 1 billion, that's still just like 9 digits. So that's really not too huge, you know? So like, okay. Actually, hold on. I said, yeah, this would be big O of n. I didn't mean like n in terms of like this n. It would actually be log n in the sense that it would specifically be log base 10 of n because it's the number of digits we're looking at. Okay, cool. Great. Let's finish up with this one. Let's get out of here.